Hello, good afternoon and good morning. Am I audible to everyone?
Yes, you are.
Yes.
So we are due to begin in another 5 minutes. So I would request all panelists to turn on their cameras, please. Yeah, so I think most of our panelists have joined already. We are still waiting for Mr. Shoboshati Bandyopadhyay, who is our organizing secretary and chief technology officer of Big River Steel USA. And I think everyone else has already joined. Okay, so before we officially commence the proceedings, I would just like to share a few guidelines for smooth platform management during today's proceedings. So for all the attendees who have joined us today on Zoom to listen to our discussion, we have a Q&A section in Zoom, which can be accessed by both the attendees and the panelists. So I would request everyone, if you have questions, you can put it there and it will be visible to the panelists who can then choose to answer it live or directly in the chat. I would also request all panelists to keep their microphone muted when they're not speaking, when the other panelists are speaking, to avoid noise feedback. And last but not the least, I would request the panelists to adhere to the time limit as given in the program. So we have a time slot of 8 + 2 minutes for every panelist. So after the first 8 minutes, I will ring the bell so you know that you have 2 minutes left and you can wrap up the discussion in the next 2 minutes. So in another 4 minutes, we will, yes. Do we have a question?
Yeah, Ankit, I think I got a list or the detailed minute-by-minute program which says 20 minutes are for Vega.
Yes, so since Vega has 2 different speakers, so we have 20 minutes for Vega.
Okay, thank you.
Yeah. Mr. Shoboshati Bandyopadhyay has also joined us from USA. Good morning, Mr. Bandyopadhyay.
Hi, Ankit. How are you?
So we will start in another 2 minutes. And I just wanted to inform everyone that my father, Mr. Nirmalya Mukherjee, who was supposed to be the session moderator for today, he won't be able to join us, unfortunately, for health reasons. And he wishes us a good discussion today and a successful webinar. And our session today will be chaired by Mr. Subrata Mitra, who is the chairman of our organizing committee and ex-joint managing director of M. Dastur & Co. Okay, so since everyone has already joined, I would like to officially start the webinar. So good afternoon to all our attendees in Asia. Good morning to everyone in Europe and US. A warm welcome to all the panelists and attendees who have joined us today and everyone watching on our live streams. After a successful webinar on Industry 4.0 and digitalization back in September, where a lot of key topics for the future of the steel industry were discussed, we are back again with the second webinar on the topic, Vega Group presents Industry 4.0 and digitalization in the steel industry in the new normal era. I would like to take a moment to welcome our title sponsor, Vega Group, and our co-sponsors, Smart Steel and Arja Steel. A warm welcome to the chairman of our organizing committee, Mr. Subrata Mitra, ex-joint managing director, M. Dastur & Co., and our organizing secretary, Mr. Shoboshati Bandyopadhyay, chief technology officer, Big River Steel, USA. I would now introduce our panelists for today. Is my screen visible to everyone?
Yeah.
Okay. So our first speaker for today, Mr. Subrata Mitra, ex-joint managing director, M. Dastur & Co. Limited. Then we have our organizing secretary, Mr. Shoboshati Bandyopadhyay, chief technology officer, Big River Steel, USA. Our keynote speaker for today is Mr. MP Dubey, Joint Director, Software Technology Parks of India, Ministry of Electronics and IT, Government of India, and Nodal Officer, Andhra Pradesh IBPS. Then we have Mr. Yatin Purandare, Chairman of Vega Innovations and Techno Consultants Private Limited, Mr. Yashwant Satam, Executive Director of Vega Group, Dr. Falk Florian Heinrich, Founder and CEO, Smart Steel Technologies, Mr. Sridhar Krishnamurthy, Managing Director, Arja Steel, Mr. Suman Das, GM, IT and ERP, RINL, Mr. Manish Bhatt, Digital Sales and Marketing, SMS Digital, Mr. Andrea Baracchini, DG and Med and Director Sales, Denali Automation, Mr. Karthikeyan PS, Digital Lead for Metals and Mining, ABB. So thank you all for joining us today, and thanks to all the sponsors for supporting our event. So our session moderator for today will be Mr. Shubhrata Mitra, who is also the chairman of our organizing committee. And I would now request Mr. Mitra to deliver the welcome address and take the session forward.
Thank you, Ankit. Good morning and good afternoon to the participants from various parts of the world. Just before getting into the topic, this country, especially this part of the country, is just passing through our annual festival. So we had been really, we had to pass in a peculiar condition, not going out of the house and enjoying. This in my lifetime, and why anybody's lifetime that was not seen. So anyway, so that may be part of the life. For let's hope the next year is okay. So India has crossed, hopefully, nicely that phenomenon without much increase. So right now, the AI or Industry 4.0, little going back, India had no contribution to Industry 1. It was Europe. Industry 2 also practically done. Industry 3, India picked up. And Industry 4, India is one of the leading powers of IT and artificial intelligence, and our people are really trying to get into it. And hopefully we will also do. Our topic is very specific. Our topic is artificial intelligence in primary and secondary steel making. We are one of the largest secondary steel making producers in the world, means with smaller furnaces, induction furnace mostly, it produces nearly 30 million, much more than many countries. So where the artificial intelligence is just a word, where the primary producers, the bigger producers have really started, the big companies, they have started their own departments and they have started machine learning. What about artificial intelligence, as we know, is basically simulation of human intelligence in machines that are programmed to act in a disciplined manner, as in short, what I understand. So these sort of things, at least in steel making, which I have, that was my expertise long back. Anyway, so a lot of things are being done. So say, for oxygen steel making, when the blowing is done, when the carbon is within the limits, the lungs will go up and the oxygen supply will be closed. This is a very small example I gave. So these things were not there earlier. So now all the big companies, they're starting this, they're increasing productivity, quality, and the utilization of machines and manpower. The maintenance plannings are also done, started to be done by AI and Industry 4. So that's a good thing that has started. All the big players in India, like Tata's, Jindals, they're very much in this field of going ahead with AI. But our aim will be to help out the secondary steelmaking sector. So we have a limited number of participants, which is good in a way, because this is a very complex and relevant subject. In future, we will definitely have a bigger platform where these things can be discussed in details with actual producers who can adopt AI and Industry 4.0. So without wasting time, I welcome once again all the esteemed panelists. The floor is open and you please share, let us share your knowledge and make us a little learned in the field. Thank you once again.
Thank you very much, Mr. Mitra. So I would now request Mr. Shobhashachi Bandopadhyay, who is the Organizing Secretary and the Chief Technology Officer of Big River Steel USA, to give his address. Mr. Bandopadhyay has a keen interest in this field of discussion, and he always gives very vibrant presentations. And the company he's from, Big River Steel, their tagline is, "We are a technology company that happens to make steel." So I'm sure that he will have a lot to add to the discussion today. So over to you, Mr. Bandopadhyay.
Thank you, Ankit, for setting that stage up, and Shubhra gave a very nice introduction to the subject, to the topic of discussion. You know, I've been in the steel industry all my professional career, and in fact, started my career in a plant which was extremely manual, and even today probably stays far behind than the most automated plants. So it was alloy steels plant, Durgapur, one of the special steels plants of Steel Authority of India Limited. The equipment that we operated and still continue to, some of them, are 1961 and 1965 genre. So when in 1990, I joined the steel industry in alloy steels plant, and I was inducted as the melter in the electric arc furnace in the steel melting shop. I used to literally run the furnace with manual jockeys. So entire control, everything was manual. I still remember those days. I didn't know how to put in computer. I was a computer illiterate completely. And used to write my logs. So whoever could write nice logs, whose logs were legible, they were appreciated, because some people were in the process of documenting all the additions and everything manually again from the logs into another logbook and into another system. So life from there. And then in 2003, 2004, I joined Stelco after immigrating to Canada. So life took a completely different turn. Where I was used to doing everything manually, everything in logs, here I come, even though Stelco was not the most automated outfit, they had level 2 automation. They had level 3 in some parts, and they had level 4 in some parts. I didn't know what was level 1, level 2, level 3, level 4. I didn't have any idea. The only thing that I knew were an electrical control panel. That's about it. So, you know, from that 1990 stage to the point now that I lead a group of very smart individuals. I have no background in software programming whatsoever, but I'm leading a group of extremely smart and talented people. And they're making the story in Big River Steel in a completely different way than what even in the last few years that I have seen. And the things that we are doing are probably very normal to everybody. You know, Subhra talked about that we would like to see more consistency. We would like to see repeatable actions. In fact, that's truth, because if you look at a quality standard, we talk about gauge R&R. Gauge R&R stands for repeatability and reproducibility. So if every action, whether be it a human being or be it a machine, if I can make it repeatable and reproducible with a very high level of consistency and a very high degree of precision and a bias, and the bias being in a positive sense, then the outcome will always become same. And the moment the outcome always becomes the same, the customer confidence or the user confidence or the consumer confidence or the developer confidence goes to a certainly very high, very highly significant level. And one other thing, if you think about it, seeing is believing, and belief drives commitment. So I always give an example. It's not in any offensive manner or anything, but if you think about the word about jihad, jihad is nothing but a dedicated soul to a very specific cause. So if those people who believe in jihad, if those are the same people who are put in the steel industry and say the jihad is AI and ML to bring about repeatability and reproducibility in your performance, what would happen? The jihad would take place. So unfortunately, we do not have all jihadis in the steel industry space. So we need a little bit of jihadi in steel industry space, at least from the top of the house, that we need this, we must implement this. See, the steel industry is very capital intensive, very highly equipment intensive. So there's a lot of money that goes in. If you think about it, $1,000 per ton of steel to do a capital cost, I mean, that's a lot of money. It's a lot of money. What's the return on the investment? How can I have a better return on my investment? What are the pain points? The pain points are very simple. Equipment downtime, non-quality product, material pricing, or material sales pricing, means our product sales pricing. So how to resolve these pains? To resolve these pains, if human mind, if human brain is still considering and doing multiple approaches, and then there are certain best practices available, how can we adopt those best practices in a very consistent manner across the entire industry? Be it in the procurement section, be it in the operations, or be it in the sales. And last but not the least, safety is premium. There are people who are involved in production. If you look at Big River Steel, we are one of those mills that are producing at about 3,000 tons per person per year. How is it possible? What's the standard or competition? If you look at India, probably, I don't know, I think they're running right about 500 or 600 tons per person per year, maybe even less. Whereas there are others of similar capacity in North America, they're probably running at 1,000 or 1,200 tons per person per year. We are running at 3,000, and we are going to be soon, by end of November, we will be 5,000 tons per person per year. We are going into phase 2 expansion. So we'll be producing 3.3 million ton with less than 650 people. So this is something that needs to be thought about. What can be done in the industry space so that we can do a better job, have our people safe, make our performance more productive, make our industry more sustainable. Tomorrow is not far behind when people will be selling steel by the amount of CO2 that they generate per ton of steel. They would have to declare that. Just like any other steel certification, they would have to declare how many tons of CO2 has been emitted to produce that coil. There will be a mandate. What are we doing today for that? There are a lot of buzz, as Subradha was saying, there are a lot of buzz about AI. Similarly, now the new buzz is CO2, carbon footprint. But what are people doing about it? How can this be brought around? And I'm pretty sure, we have a lot of people on the panel. I'm looking forward to people contributing. Unfortunately, I have a schedule. It's very early morning here. I have already some meetings scheduled, so I would not be able to stay through the entire session, but I wish everyone all the best. And as Ankit and Nirmalia continue to, bring these platforms to our fore, I'm extremely privileged and honored to be part of this and have this platform here for interaction. Hope the industry benefits out of these sessions. Thank you and all the best.
Thank you, Shobhushaji, for a concise but nice, relevant talk, which opens up eyes in different areas like safety, quality, productivity. That's what we want. And the last but not the least, CO2. Yes, the world will ask for a report on CO2, how much CO2 you are emitting. So, well, that was well presented. Now you have a program. So we hope you continue, but you have to attend something. Thank you once again.
Thank you.
So thank you so much, Shobhushaji uncle. As always, your address was very precise as well as passionate. So since Mr. Bandyopadhyay will have to leave soon, I would like to ask the panelists, do we have any questions for Mr. Bandyopadhyay? Anyone would like to ask anything or comment? Anyone from the panel? Okay, so in that case, we will now move on to the proceedings with the national anthem. I would request you all to please rise for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Okay, so first we have the keynote address today by Mr. MP Dubey. So Mr. MP Dubey is the Joint Director, Software Technology Parks of India, Ministry of Electronics and IT, Government of India, and Nodal Officer, Andhra Pradesh IBPS. Thank you very much, Mr. Dubey, for joining us today. And I would like to request you to please deliver your address now.
Thank you very much, Mr. Ankit. And really very nice talk by Mr. Bandyopadhyay. I like your way you have given the whole picture of this industry. Now that's why you must be knowing that we are coming with a Industry 4.0 Center of Excellence, where under the dynamic leadership of CMD RinL. So this is basically the problems we try to highlight more and more the steel plants which are facing because of technology is not been adopted. If you see, the steel plants were very old, but the recent one, your aircraft and other, which are recent, I think 40 years, 50 years ago, but how much technology they have taken in their overall ecosystem. Whereas if you see steel plant, the ecosystem, very less number of, I think, IT is implemented. So that's why the Government of India, I will just share my presentation, Government of India is setting up a Center of Excellence on Industry 4.0 So this is already you have spoken. So basically in the digital age, an organization should adjust their production and logistics system to meet new technologies. And that's how the main criteria is the cost efficiency, customer centric, flexibility of production, looking at overall the growth of industry 4.0 will play a very vital role for the growth of any company in terms of productivity, in terms of profitability of the company. So that's why the industry 4.0 is come the industry 4.0 with 9 different areas we are working is called TIDE Center of Excellence. On industrial robotics, we are doing a lot of innovations, lot of work, simulation, system integration, Internet of Things, IoT, industrial IoT, artificial intelligence, industrial drone, cloud computing, additive manufacturing, industrial 3D printing, and big data. And with this, we have recently added is AR and VR. These are all emerged technologies, and how these emerged technologies is going to implement in the steel plant overall for the growth of the industry 4.0. That is the thing. I just like to show you some of the industry 4.0 which are using in I think the overall, and the government of India is already putting a lot of, we also put a lot of effort in the, it has come in the budget as a emerged technology. Wherever AI, ML and bioinformatics kind of things we are using, we are giving more and more incentive to those industries. So this is one new thing is AR, VR, which we have added. Because of time constraint, I am not going to show you the whole. So how basically through Google Glass you can simulate the activities. That's the thing. The cloud computing nowadays, wherever the your developments are going on through technology, you can do it like see the car manufacturing, and overall these are everything is correlated with the data. AI data, IoT, when come together and goes to the manufacturing side, it will create a very win-win situation for the industry. So this way, artificial intelligence, we are, whatever center of excellence we are coming, that's I will come in another 2 slides. AI is our main focus, and Government of India, Ministry of IT is putting more and more effort on AI-based implementation of Industry 4.2.
One area.
You see, this is the
product quality. Big River Steel is addressing variability in mechanical properties, yield strength, tensile strength, and elongation.
And most AI is using for their steel making factories. And robotics is one of the area which we are working very closely with the industry. What type of basically robots are going to implement for the steel kind of industry? And this is the area of work which we are working. And if you see the global AI market, there is a huge growth overall. And that's why you see when IoT and AI work together, it will create the overall manufacturing process faster and much better. So this is just, we are showing you some of the videos just to know about overall. The Government of India, MITI, is already pumping a lot of effort by creating Center of Excellence across the country. And this is the Center of Excellence which we are set up in Visakhapatnam is Industry 4.2 under the leadership and able chief mentorship by CMD RinL. And this COE consists of artificial intelligence, machine learning, industrial automation, industrial robotics, industrial drone, industrial IoT, industrial 3D printing is one of the very latest technology we have added across world. Very few places only this. We are going to now, this COE is going to manufacture also state-of-the-art 3D printing and AR/VR related technology powered by AI. This is the government thinking that everything should be powered by AI. So these are certain problems of the steel plants we have already identified, like cleaning of converter oxygen lane using robotics arm in LD converter of SMS. Then IoT-based vibration load sensors for critical equipment like lens driving converter. Then SMS caster data analytics using big data for predicting issue that may arise during casting. So there are we have already identified certain problems also. Now these problems we are going to give to the young talent, and those talent will able to bring out the solution. This is the basic idea of this industry 4.0. Basically on steel industry we are working to bring more and more flexibility of the center of excellence. This is the center of excellence the government of India set up across India, and Visakhapatnam has been chosen for industry 4.0 especially for the steel industry. We call this as a smart UKU. UKU means steel. And these are the overall center of excellence we work. We work with industry, we work with university, we work with education institute. And overall, if you see, this is the first cut view of the operations which are coming. And here what we are doing, segregating. So this type of where image processing are going on, including the your computer graphics. So basic the center of excellence. This is the center of excellence which we are running now. This is called transformation of industry through innovation and entrepreneurship development. Is called Tide Industry 4.0. And this was the government agencies which are involved in this are Ministry of IT, STPI, Arja Steel, that is RinL, and the government of Andhra Pradesh. To nurture more and more problems, we have taken industry leadership also. To part of the mentorship program, RinL is there, SMS Steel is there, ABB we are talking, Siemens is there, and EOS is basically helping us on 3D printing. The industry associations are there like CI and ITAP, and academic partners, IIM is there, and this we are creating an ecosystem for innovation for making a successful venture industry 4.0. So we have a innovation center of 10,000 square feet. We are coming with a state-of-the-art laboratories looking towards the steel-based the industry 4.2 applications. And the government of India also, we have already chosen around 30 startups who are working on this area, where the seed fundings are also based on their ability. The government of India also giving the seed funding, initial level funding, and after that they can get the funding from other sources also to nurture their product. So this is the IoT lab, and if you must be knowing, now sitting a engineer in Germany can through 5G and IoT application can able to deliver the work from South Korea. So like Bandhopadhyay is sitting in US can also help our Visakhapatnam startup COE by giving the technology is already available. That is the thing I am saying. So the robotics area already, Visakhapatnam, you must be knowing, we have lot of robotics centers here. Especially we are developing those robots. You must be seeing the hand robots which we are developing here is for surgical robots these are. And a similar kind of high-end robots we are designing for the steel-based manufacturing component. You see one of the robots which here developed in Visakhapatnam is used for physiotherapist. So the already that implies, and another you see the kind of now the hand robots are so powerful. If you have certain problems, those problems can be easily solved through the two robots. Robot hand can. We don't require a complete human robots nowadays. Two hand robots can do maximum kind of work. That is the thing. And you see the kind of the chair which is going to is been done by two hand robots. So very sophisticated, which we have an ecosystem in Vizag. Many robots were been designed, developed. Similar things we are going to see what type of robots is going to use for our steel industry. We can, which are the places, which are the problems we can solve through this. Drone is another area which we are developing the drone, and already 5 manufacturing industries already here. Basically, we are thinking the drone is basically to find out your stockyard areas with tagging and other kind of thing. 3D printing, we have one of the Asia's biggest 3D printer in Visakhapatnam. And this is the picture of the 3D printers, and the 3D printer day by day what we wanted so basically we are from Visakhapatnam we are manufacturing the here also the 3D printers. So if you see over the period of time we are going for a complex level from the steel plant. The basic idea of why we are choosing 3D printer, over the period of time the complex component can also be done through the 3D printing straight from the SMS. That is the basic. We thought our some of the problems are there. So the manufacturing of a complex 3D printer also be possible. We are able to develop in this center of excellence. Now, if you see the industry 4.2 in primary steel making and how the COE is helping is that the industry should have matured level 2 system with mathematical model for automatic blowing and scheduling of heat metal and continue casting shop. On top of level 2 system, there shall be manufacturing MES between ERP and level 2 system, and high speed internet is required whenever you go. So what there are many problems like AI/ML based solution can be attempted in the area of chemical prediction, mechanical properties in blast furnace and other kind of casting areas, rolling mill areas. These are the problem. The essential spare parts which are not you are not getting. So 3D printer can play a very vital role on making the the spare parts through 3D. Already our 3D printing machines are already doing this activity, and there are many activities are there like AR VR based goggles which are now using in some our COE for maintenance of equipment can be effectively used by operators to see through the equipment history while working. So nowadays technology based driven steel plant will make more and more profit. That's the basic theme of my talk is. And the industry 4.0 technology can be explored to implement in the following area of steel plant. One is production and productivity, industrial safety, employee health and safety, structure and equipment health monitoring, pollution monitoring, maintenance, product quality, waste reduction and logistics. And this is the milestone for our Industry 4.0 Center of Excellence, and already there are 25 startups who are working here in different areas. And recently we have given another 24 which are on pipeline startups on different areas of Industry 4.2. So we thought India, this is our Digital India campaign from our ministry. With this, thank you very much.
Thank you so much, Mr. Dubey, for a very interactive and interesting presentation. So since you also mentioned Big River Steel in your presentation, I would request Mr. Bandyopadhyay if you would like to add something. I remember in the last webinar when you spoke, Mr. Bandyopadhyay also mentioned, he suggested that the focus of the centers of excellence should be on closed loop systems for quick decision making. So Mr. Bandyopadhyay, would you like to add anything to that today?
Yeah, Mr. Dubey, as usual, very, very informative, and I'm really impressed with the kind of work that your center is doing. Yes, so as you are focusing on robotics and overall artificial intelligence, I would say that think about the pain points that we are having in the steel industry. I'll give you a very specific example. You also mentioned about AR/VR and maintenance monitoring and all that. So think about situations where caster is casting, and in our process, we can see whether the defect is coming through or not after the rolling of the steel. But in many cases, like a plate mill or even a thick slab cast or conventional hot strip mill, they don't see the defect in the coil till they roll it. And that could be many hours at least, and even in cases, many days. And those defects are originated in the casting, in the continuous casting. And most of the defects, Mr. Dubey, originate in the mold section, in the containment zone. Now, there are also certain defects that are created during the secondary cooling. But think about this. If there could be a program by which we can first detect, second predict. So first detection, second prediction. So prediction will lead to avoidance. That means we will be able to change the process to not even produce non-prime material. If you look at globally, I mean, let's say we are 1 billion ton of steel production in the world. I'm just giving a very simple mathematical number. 6% of it generally considered as non-prime production, generally. So that means we are talking about almost 60 million tons of steel that is non-prime every year for a billion ton of production. 60 million tons of steel at the rate of approximately $400 per ton of primary steel making cost. That amounts to almost $2.4 billion. That's huge. So that's where I think this is where value can be driven by working through primary end, where most of the raw material cost is going in, because about 55 to 60% of the entire steel making cost is upfront in the primary area. And mainly, as we are switching more and more towards EAF-based steel making, the costs are going up. So that's where the costs lie. So if you look at scrap or iron ore or coke or alloys, ferroalloys, and energy, the primary end of the entire primary and secondary steel making end of the process. So making steel, the melting steel, that augments all the cost, almost all the cost that is involved in the final product. So I think if you can please focus on how to detect defects and then predict defects and then avoid those defects so that actions can be taken. So dynamic, more as a dynamic in nature.
Yes. I think this is a very good problems you have told. We will take up this through some of the startups problem areas.
Thank you.
Thank you very much, Mr. Bandyopadhyay. So anyone else from the panel would like to add anything or any questions for Mr. Dubey? Okay, so in that case, we will be moving on to our presenters from the Vega group. But before that, we have a short corporate video by Vega group, and I would like to play that now. Is my screen visible to everyone?
Yeah.
Yes.
We help manufacturing enterprises remain innovative, remain competitive. Our vision is to create continuous value for its customers by leveraging fast-changing technologies. Our mission is to offer end-to-end automation to steel manufacturing industry to enhance their performance, productivity, profitability. We provide industrial connected solutions that lets enterprises make their manufacturing business more competitive by carrying out Industry 4.0 aligned digital transformations. Why Vega? We have exhibited industry application know-how with domain. We have technical team with exhibited experience in design, engineering, manufacturing, implementation and support. We have key focus on innovation and continuous improvement. And, supported by strong R&D expertise. Vega Group's companies brings different capabilities together to help customers successfully align with Industry 4.0. Contact us to embark upon your Industry 4.0 journey.
Okay, so I would now request Mr. Yatin Purandare, Chairman of the Vega Group, and Mr. Yashwant Satam, Executive Director of the Vega Group, to give their address.
Thank you, Ankit. It was good evening to everyone, and thanks for joining the webinar sponsored by Vega Group. My earlier panelists have literally created a very nice stage for Industry 4.0, coming from, let's say, steel industry, their problems known, what are the solutions getting applied, how the government is trying to improve and enhance this structure of leading Industry 4.0 exercise in India. One of the key things which I could mark out was a benchmarking by Mr. Sabyasachi about tonnage production per person per year. I think that could be one of the very good guidelines for all of us in the industry to decide and work and improve towards it. Mr. Mitra's address consisted of secondary steel, almost 30 million ton, rightly said the production is more than many of the countries. We are going to focus mainly on secondary steel because the primary steel producers have got their internal capabilities as well as affordabilities to go in for higher end technologies faster. It is the secondary steel sector which has either infrastructure limitations or the kind of team which supports supports the Industry 4.0 exercise in the businesses. So I'll just start my presentation and how Vega has worked with secondary steel sector and what are its proposed plans to take Industry 4.0, starting with baby steps, ending with complete 4.0 solutions for secondary steel manufacturers. Ankit, can I share my screen?
Yes, you will be able to share your screen from the share screen option.
Okay. Just a minute.
So at the bottom of your screen, there will be a green button called share screen. And if you click on that and click on the presentation, then...
I am not seeing my...
Okay, so first you have to... Yes, we can see your screen now.
Yeah. I
Yeah.
I'm sorry, Ankit. Yashwant, can you share the screen? I'm getting some problems in sharing my screen. Hello.
What you can try is you can maybe I will stop the sharing now, and you can open the presentation and then try to share the presentation again.
Yeah, let me see.
Yeah.
What I can do is I can share the presentation and he can talk
Yes,
about it.
that is also fine. Whichever is more convenient.
Okay.
Yashwant, I can do that. Should I start? I got the share window here.
All right. Okay. Yeah, yeah.
Great. So can everybody see this?
Yes. Could you please turn on your video?
Yeah.
Yeah. Yes, perfect.
So Industry 4.0 is a very large subject, and since we have time constraint right now, I would like to focus it more from, let's say, management and processes perspective rather than technology perspective. Mr. Dubey gave us a very good idea of various technologies which are involved in Industry 4.0 as a broad subject. I would rather like to take it more towards, say, the practical working of it and what are the key benefits one can get in the process while doing that. So we will cover this in a few parts. What is the impact of Industry 4.0 implementation? What are the solution impacts? Certain examples which Vega had been working on, and a quick wrap up. So just imagine what data we require is easily available in a real time without any human intervention. Parta is a very common term used in industry where we try to know what is going to be my daily contribution in terms of average sale price or average purchase price, what is my cost of consumables, what is my cost of labor, what is my cash flow. Imagine these or this type of data, then let it be for production or maintenance or for logistics or for sales, available at fingertips, which changes the decision-making power, which improves the performance pretty fast. And Industry 4.0's basics start here, where the data has a primary tool to derive and offer the users required information to take quick decisions. Looking at Industry 4.0, is it a technology or the applications? The technologies are just the enablers, they are the tools, but what kind of applications we try to derive out of it is very important in Industry 4.0. What generally everyone wants is authenticity of the data. That means we are getting a true data, the transparency of the data naturally, the real-time data, what are the compliances we are following, which are easily surfaced through the practices rather than Excel sheets, and of course the mobility. If the data is available everywhere, what is going to happen? How the things will move faster, the decision making is quicker, as well as everybody can get the data without demanding to act upon it. So Industry 4.0, as Vega has conceived it, works with connected world. So fundamentally, if everything gets connected, your processes, your machines, your people, your systems, your management, automatically the transparency of data is quite high, and that data can be eventually used further for improving the processes as well as the efficiency, productivity, which was mentioned by earlier panelists as a key feature what industry needs. So having a stable, consistent process, having minimal wastage during the process, getting 360-degree information in production planning, maintenance planning, raw material, supply chain planning, understanding the impacts of these plannings and raw material on a cash flow, so better financial planning, and naturally work towards the final customer, higher customer satisfaction, and try to get more and more market share. Overall impact, improving business by 360 degrees is northbound, southbound, eastbound, westbound operation within the business. So it doesn't restrict now only to the process data, but also extends to business data. So when all these systems are connected together, automatically the common foundation of data allows the users or managers to take a right path in achieving higher performance. Mr. Dubey explained about Google Glasses. Vega also has a startup company who has introduced AR, VR based connected worker philosophy in this Industry 4.0 segment, especially during Corona effect and because of migration. The cost of training is going very high. So 4.0 technologies try to achieve a fundamental level of automation, and where the last mile services are required, such connected workers through augmented reality based technologies and solutions can connect to the machines and do the job at a faster rate. And as he gave the example of South Korea, probably a person sitting in Germany can give advice to the person sitting in Calcutta or Delhi, and the business as well as the problem solving capabilities move faster. So what is the impact of Industry 4.0? If we really look, let's say we go anti-clockwise, improved manufacturing operations. What does that mean is we get a real-time status of pre-operational status of raw material, spare parts which are required, my roll shop, guide shop requirements, consumables, the real-time upstream process values, downstream process values, real-time asset status. Is my asset going to fail in certain number of hours, so that I can have a proactive planning of, let's say, predictive shutdown or change of campaign to avoid my breakdown time. Real-time chemistry, quality parameters from melt shop area available to rolling mill. Real-time water parameters are available to quality control lab in the rolling mill. And rolling mill results can be displayed or made available to the melter. Synchronizes the operation of this integrated steel plant, whereby each of the right decision maker can take a right action and avoid wastage. When we talk of manufacturing processes, the real-time value of cost of production, cost of electricity. Electricity is the second raw material in the steel. What quality I am producing. Mr. Bandyopadhyay specifically mentioned about casting quality. Yes, that's a very niche and critical area where if we can understand upfront about the casted quality, we can avoid failures in the rolling mills. Cost of consumables, what is the conversion cost I am getting? So manufacturing processes get the data from machines, get the data from processes, get the data from, let's say, ERP systems about stocks, get the data from asset management systems about the asset life, and coordinated on a centralized planning through MES systems for sales to production. will synchronize again all these systems together. What another impact it will cause on is a improved business operation. So naturally, our customers are keen to understand when is my delivery going to come, what is the status of its production in the plan, or if it's running. Can I get online quality inputs of my product which is getting rolled or getting manufactured? So this transparency of this data can be extended to the required stakeholders, whereby they are more confident about the quality supplied to them, at the same time the true information received by them. So this collection is another area which tries to give good inputs to the finance teams for planning, raw material cash planning. And of all the things, whenever we are connecting these manufacturing processes, machines and people together, there is a lot of data which is generated, which is collected for probably using it as a value-added solution or root cause analysis in a long run. And what is the final result is improved market share. My customers are happy. My customers get the data which is as is rather than which is filled in. So naturally the level of confidence and the quality assurance is well guaranteed in that, and makes us demand some premium in the market over our competitors. So added to this, the visibility to the required functions keeps the processes on track. So if a maintenance person knows when the asset is going to fail, or if he knows that, okay, if I have got my certain part which is going to arrive after 8 days. So these kind of visibilities help him to plan his schedules or campaigns very well. The financial data helps to control the financial, let's say, collections and payments and disbursals and raw material planning. The manufacturing data, like what is my consumption of electricity, that will help the melter or rolling mill manager to check into the problems right away and restrict them before they get ended up by the end of the day to realize and act upon it in the next campaign. So we have a few case studies here about Industry 4.0 solution impact. Actually, we are going to go with the first baby step, which is a traceability, a simpler application to understand its importance as well as understand its effects. So the state today is a discrete process management, especially the raw material handling, melting and casting usually go together. But post-casting, reheating, rolling, yard management, post-rolling processes, they are all individual processes and need a lot of coordination between these processes through the managers and skilled personnels. Industry 4.0's first step we identified in terms of traceability connects all these processes together. By collecting the data, first is the relation building between raw material to finished product is easily achieved. On one area, it tries to give the impact of getting a single QR code, having entire information of grade mix, the melting data, the chemistry, the quality data of the rolling, etc., etc. On the other hand, it has also collected huge number of parameters, typically parameters about 50,000 parameters per, let's say, 100 milliseconds. And now to use that data to model individual process and optimize it for better performance is the key thing. So how this digitalization, how this integration is digitalized as a sample case is right from scrap management, which is a sort of a ERP function of purchase management, to scrap handling, scrap tracking, to the furnace shop, furnace, and understanding the charge mix grade, measuring the tap, checking the ladle sequence, up to the caster, synchronizing caster with the furnaces. So understanding when the caster tap is getting over, and a proactive information fed to the furnace reduces the idle time of the ladles. The casted billet is related to the chemistry data and other quality data. So whenever it goes to the rolling mill, its whole genealogy is known and the rolling performance is calibrated along with that. The produced bundle on the cooling bed now has rolling mill quality data. You have a casting quality data and you have a melt shop quality data. So one QR code has entire information about the product which is produced and the authentic information of it, because the data is collected from the machine and not fed by the human being, which might be error prone. So traceability could be one of the baby step which is started. If my customers demand such processes, I adhere to these processes. If they don't demand, still it gives me a consistency of my production as well as the data which is to be used in future for improvement of the processes. So how this data can be leveraged in various areas. So today, let's say in a melt shop, we can reduce the idle time of the ladle by sequencing it. Online spectrometer results can be displayed to the platform, to the furnace operator for his quick actions. Controlled ferro additions help to reduce the cost of high cost material, high cost alloys. Refractory life management, getting a factual data and optimizing its usage without compromising the safety. And of course, second step could be understanding what charge mix gave what quality, slowly learn through machine learning and create a model of charge mix based on the quality which is demanded by the customer. On the caster side, we can also again look for the ladle tapping early warning system, whereby we do not have a breakdown, blackout, or we do not have idle time of the ladle which is waiting and creating energy loss. Mold wear out patterns, data which is generated, which is reflected to the final product quality, let's say in terms of rolling or in terms of casted billet, can give us a certain pattern in future which can be used to correct the mold sequence or mold oscillations and control the output of the mold in a right fashion. Like refractory in the furnace, we have a turnish refractory optimization possibility, and as adjust the secondary cooling, water flow based on the actual quality of the billet and billet temperature. So these are all conditions in real time. It is very difficult for operations people to control. And when machines, auxiliary systems, as well as machines start talking to each other, the decisions are made at their level and the information is passed to the supervisors, what action has been taken under what condition. Coming to rolling mill, one of the last end of the steel production is identifying the reasons of cobble. Usually in secondary steel, the cobble percentage of, let's say, 0.3, 0.4% is accepted. But why that cobble has happened has got multiple number of variables and are very difficult to track down. Once we have a complete end-to-end information about the charge mix, the melting properties, the casting properties, it would be easier for us to understand the cobble and take actions to reduce the cobble rate further, which is directly money. AI and robotics, the critical areas, especially in secondary steel market now, since the productivities are increasing and because of induction furnace route, sometimes slitting is not possible. So high-speed rolling mills is a very crucial aspect of controlling it, old post-rolling, that is a bar handling area. Introducing robotics in terms of, let's say, operatorless controls for these areas where the bar is tracked and parameter settings are automatically done, eliminates the cobbles in that area, gives a safety to the operations team because they don't have to be near the machine. and information is passed on to them. Controlled operations, again, as I was saying, if I have all the data of, let's say, quality data of billet, and if I understand what is the reason of cobble, what is the reason of, what is the temperature of the billet while entering the rolling mill, how much prop cut I should keep so that I can achieve a better or best yield. The idle time in the mill, again, we need to have a root cause analysis, because that is where the productivity is directly dependent. The larger the uptime, the larger the productivity is. Same goes with asset management. The asset life can be calculated based on this data, and proactive warnings can be given for its forming a maintenance schedule. Auxiliaries is the area where actually people really do not look into closely, but still they contribute about 10 to 15 units cost in the whole steel production. Monitoring each and every auxiliary system will help to eliminate the losses in terms of power factor or, let's say, over design of the equipment. At the same time, avoid the failures which may cause the breakdown in the main processes. So connecting auxiliary systems with the main processes as a control part is a part of level 1 system, but understanding the importance and operational, let's say, performance of this auxiliary system with respect to the product produced, we can very well control the costs by controlling the energy as well as their performance or failure, controlling the failure rate of such auxiliary systems. Now, is this all achievable? Because as we look into this, it looks like a very complex process, but with today's technology in telecommunication, IIoT, these all are feasible. So Vega has prepared a broad architecture for Industry 4.0 long-term solutions, which basically contains a common IoT data platform where entire plant data, let it be process data, let it be business data, let it be information coming through your emails or WhatsApp, is gathered together, and which can be correlated to form different applications in different areas, module by module. So no need of full investment altogether. Go baby steps, achieve one part, reinvest whatever earned back into the process, and head towards Industry 4.0 compliant company in future. So this is what Vega's product map is based on the architecture. So we have process automation systems, production operation automation systems. We have ERPs, SAPs, or similar products. Vega SimplyWorks is one of the product in that category. We have SMS, WhatsApp, email, websites, data connected to this platform. I get LME or RBI dollar rate every day in the morning, automatically downloaded in the system without any intervention. Machine learning is used for collecting mail information and converting it into the data which is useful in the system. And then we have a traceability, asset management applications. We have optimizing applications. We have connected worker or operator 4.0 through AR/VR solutions. And we also have artificial intelligence based modeling, analytical modeling, and robotic controls over and above these platforms. So what are the key takeaways I would say, I would suggest in this is the quality and processes as well as stakeholders data transparency. Avoiding human data entry makes it a zero error data. Real-time data helps decision makers to take quick decisions. Data everywhere, mobility saves time. So no data needs to be demanded. I can get the data what I want. And once I have this all data across the board, a continuous improvement process is a ongoing exercise steel plant can do to improve its productivity and efficiency. Thank you.
Thank you, Mr. Purandare. Thank you, Mr. Purandare. It was quite an elaborate. I just had one question, if others have. Is Vega working on also the environment management package for the secondary sector, which is not in a very good shape? If not, I need not want the clarification just now. You can send it later on.
Sure.
How to handle that part of the subject? Because the bigger players, bigger arc furnace operators, they have all back filters, all facilities. These people hardly have anything. Anyway, that was what I was thinking. So you have really elaborated this. So I have nothing else. If anybody else has anything.
Sure, Mr. Mitra. I'll come back to you on this.
So we have a question from Mr. Yogesh Kumar Patel. He wants to know, he wants you to elaborate a little more on bottom stirring and ladle tracking and management system.
Basically, the ladle tracking and induction furnace automation is handled through its own identity markers. Each of the ladle has got its own identity. Each of the furnace has its own identity. The furnace automation system is coupled with the data system, and the ladle movement is tracked because of their identity throughout the plant and related to, let's say, tapping to casting process. Was I right in answering your question, or was it a different what you want to ask?
So, Mr. Patel, I have permitted you to talk. You can unmute yourself and ask any follow-up questions if you have.
Thank you, Mr. Ankit. Am I audible?
Yes, we can hear you.
Thank you for your kind permission. So I just wanted to know, because this ladder tracking system in our steel industry is an important aspect, and this has not been addressed, I think, in the past. But nowadays it is being felt that ladder tracking system should be there. So is there any package you have developed for ladder tracking and management, both? So tracking as well as management, yeah.
Yeah, so the traceability is one of the module is ladle tracking, where you are in a melt shop area, in the furnace area. And as I was explaining, each ladle is defined with unified identity, and it is tracked in the plant for its location, for its idle time, and also related to the furnace ID, so that it is known that which ladle holds which tap or which heat.
Okay, so what technology we are adopting for this tracking?
Here we have adopted a special RFID technology and connected with, let's say, the furnace automation is connected on OPC. The weighing stations are connected on Ethernet TCP/IP Modbus.
Okay, thank you, sir. Okay, thank you very much.
So we have another question from Mr. Rupesh Kumar. Mr. Kumar, if you could please ask your question. Mr. Rupesh Kumar, can you hear us? Okay, then we will now move on. Anyone from the panel would like to ask anything to Mr. Yatin Purandare? Okay, so we will be moving on to our next panelist then, Dr. Florian Hendrik, founder and CEO of Smart Steel Technologies. So Smart Steel Technologies is a company that is based off in Berlin, which is very close to where I live. And their technologies have been recently adopted by ArcelorMittal in their plants in Eisenhüttenstadt. Correct me if I'm wrong, Mr. Hendrik. And they are also planning to implement Smart Steel Technologies in their plants in Duisburg and Bremen in the coming days. So over to you, Mr. Hendrik. Herzlich willkommen zu unserem Webinar, and you may begin.
Thank you very much. I would like to go into a topic which was mentioned during our webinar today already, namely into the topic of casting. And for this reason, I share my screen. Just 1 second, please. So, okay, so my topic today is a short introduction on how to reduce surface defects which originate from casting using methods of AI. And we applied this approach to casting machines and in particular to the production of STIF grades with applications in the automotive sectors, with applications on exposed parts. And this means with applications where the surface quality of the rolled and galvanized sheet is of utmost importance. What I will present is a solution which has been implemented already, which is in production already for a couple of months, and which is based on ready-to-use software packages developed by my company. The basic takeaway that I would like to emphasize is that we achieved a 50% reduction in defect rates on automotive exposed sheet. Our approach is based on a software platform which we call the Steelmaking platform. On top of this, we offer multiple ready-to-use software packages for different aspects listed on this page. Today, I will only consider the casting optimization AI. And the purpose of this package is not only to predict quality or quality defects, but instead to avoid quality defects in the first place by automatically computing optimized settings for the casting machine. And up to my knowledge, this is the only application, successful application of AI in the steel industry up to now, which actually results in a 50% decrease in surface defects verified in production. There's, up to my knowledge, no other supplier who has a similar solution. But before we go into the details, let me shortly at least list the areas where you can save money when you apply artificial intelligence methods to the casting process. The first area is slab and coil downgrades. And in particular, those are very costly if you can only discover the defect downstream after processing the coil in the hot rolling mill, processing it in the pickling line, cold rolling it, and finally galvanizing it. So for instance, sliver defects can often only be detected after galvanizing at the last step, and this is extremely costly. The second area is energy. If you manage to reduce the defect rate in casting permanently, then you can move certain steel grades from cold charging to hot charging. Third area obviously is production throughput. And finally, there is also the opportunity to reduce the slab repair costs. For a 5 million ton plant, a solid estimation of the savings is 6 million euros. This is a very solid estimation from my point of view. Our approach is divided into two components. There's one component which we call planning optimizer. This one computes optimized settings for each individual slab, each individual heat, for each individual casting sequence. And this component is doing this online. So we have a full live integration with the IT systems of the steelmaker. And this planning optimizer utilizes 100% of all available historic process and quality data to compute the optimal settings for the caster individually for each slab. The second component is what we call Life Optimizer, and this part supports the operators to reach the highest precision in casting and also in secondary metallurgy. So the second component contains live models which are integrated live into the process. Implementation of a project like this for a typical flat steel maker takes 6 months. It is subdivided into 4 steps listed on this page. Step A is where we install ready-to-use components for each surface inspection system. This means we install classifiers for surface defects at the hot rolling, pickling, and galvanizing steps, and we install a centralized coil map which maps all surface defect information into a central coordinate system, and thus creates a digital twin for each coil being processed in the plant. Step B on the top right is the actual automated transformation of all data back to the position on the strand, and the automated merging of quality and all process data from the caster, level 1, level 2, and from the melt shop. Step C is an AI-based transformation of the merged data into a format which allows you to get insights, to get direct insights into the feature space of the caster. So at this stage already, you can check directly correlation between certain casting contacts, casting parameters on the one hand side, and the quality results on the other hand side. And finally, step D is the implementation of the fully automated computation of optimized settings. So just to make this point clear, because this is quite, the misunderstandings might happen, the system computes automatically the optimized settings for the casting process in order to optimize the quality. Yeah, so there's no intervention necessary by technologists or something. It's fully automated. And on top of this, the operators are supported by live modules, which help them to actually achieve the planned settings. We have done this with multiple plans. On this slide, you see a list of some of our references, and we are looking forward to implement this in as many steel making sites as possible. Thank you very much, and I'm open for questions.
Thank you very much, Mr. Hendrik. So you finished your presentation well within time, within 8 minutes. So do we have any questions from the panelists?
Yeah, this is Shrila. I was wondering if you had any similar solutions for long products.
Yes, we have. Yes, we have. With long product, okay. Depends on the type of inspection lines that you operate. And it is also, this was also mentioned previously already, it is very important that the material tracking between casting, rolling, and finishing lines is in place. So you really need a working material tracking.
Okay, yeah.
Any more questions from the panel? Mr. Shubrata Mitra, would you like to add anything to the presentation? You have to unmute yourself, Shubrata Uncle.
Yes. I think there is a question in the chat room where one person asks if it is possible to get the slides. What you definitely can get is there's published articles about this technology. They are also available from our websites. They are published in Stahl and Eisen, in Steel Times International, and so on. So there's publicly available information about this technology.
And if you want to watch the webinar again, the entire webinar is being live streamed and it will be available on our YouTube channel as well as our website. So Dr. Heinrich, we have another question from Mr. Patra. He asks, how do you capture surface defects of coil? Is it any equipment like Parasitec?
What we do is the following. We use the existing surface inspection hardware, but we replace the software. Usually flat steel makers have surface inspection systems in place at the end of hot rolling, pickling, galvanizing. And the hardware, the camera hardware is fine, but what we replace is the classification software for the defect images. So this is replaced by our software, and then we can derive valid target signals from this.
Okay, so I think Mr. Patra has a follow-up question to that. Mr. Patra, you may please ask your question now. You may unmute.
I had a problem with my speaker. I'm Mitsa here.
Okay, are you able to listen me, Dr. Henrik?
Yes, I can hear you.
Okay. Now, there are online surface inspection system in few mills. So all those surface inspection system has their own classification software. So you have your own classification. So these two can talk to each other, or how it works actually?
We have our own classification software based on deep CNNs that we developed in-house, where we designed the neural network model specifically for hot rolling images, another type of model specifically for pickling images, and another types of model for cold rolling images and for galvanized images. And what we do is we connect to the existing surface inspection systems. We do use the existing hardware, so you don't need to install new systems, but we ignore the existing classification software because usually the classification software provided in those surface inspection systems is unreliable, and it is definitely not suitable to be used for process optimization.
It may not be so because some of the systems are quite matured, and that is also used for product release, not only process control, but also for product release. I mean, and another thing, the second question is that you are telling that your system can directly control the process. So is it, I mean, it can be connected to the level 2, existing level 2 of the casting rolling equipment?
As our systems are directly integrated with the level 2 of the caster, and they are directly integrated with the production management system, and they also get fed by data from the level 1 of the caster and the melt shop. Still, the operator of the caster has the option to accept the recommendations by our systems, or he also has the option to reject. So the operator has a final control.
Okay, okay. So it is, it basically it's a software tool working by, okay, there is, okay, thank you.
You're welcome.
Dr. Heinrich, just one question, just 1 minute. Ankit, just a minute. What is the heat rate roughly? Because these are basically calculated based on software. Heat rate, HIT, means heat rate should be nearly 100%. of the quality findings?
Our approach is to automatically compute caster settings which avoid the formation of surface defects in the first place. So,
okay.
Yeah, so we can also predict quality, but we go one step further. We automate the configuration and settings and operation of the caster in such a way that the quality defects are avoided in the first place.
Okay, thank you.
You're welcome.
So, Dr. Hendrik, could you tell us a little bit more about the classification model you talked about, whether you're using convolutional neural networks or recurrent neural networks?
For the classification of the surface defect images, we use deep CNN architectures, which we have developed in-house. We designed those architectures specifically for hot-rolled steel images, for pickled steel images, for cold-rolled steel images, and for galvanized steel images. And we put a considerable time into tuning of these architectures.
And do you have any figures for the accuracy or precision that you are getting from these models?
One has to be careful with percentage numbers in these cases, because the relevance or significance of these accuracy numbers depend on the quality of the test set which you use to compute those numbers. So what I mean to say is, if you have a difficult test set, a challenging test set, and you reach a relatively low percentage number on this difficult test set, this is sometimes better in practice compared to a situation where you have an easy test set and reach a very high number. So for this reason, I would say I can state that we are much more accurate and robust in detecting complex surface defects, for instance, sliver defects, which are a long-standing topic of optimization in the steel industry.
Okay, thank you very much, Mr. Hendrik. Und vielen Dank für eine so wunderbare Präsentation. So I would like to move on to our next speaker. We have Mr. Sridhar Krishnamurthy, who is the Managing Director of Arja Steel India. Over to you, Mr. Krishnamurthy.
Hello, thank you, everyone. So far, it's been very interesting, and I can already see some potential problems that I have could be resolved by what Dr. Hendrik has in mind. So let me just share my presentation. Can you see the presentation?
It is starting, I believe, not yet. Yes, we can see it now.
Yes. Okay. So thank you, everyone. So I have a few slides to illustrate a little bit about what the company is about, and then later some examples of how we have used certain technologies to help business. Because what I tell my IT person is, whenever it comes with some complex project, I say, how is it going to help business? Because yes, there are certain things we do for the fun of doing it, but in the end, it has to have a business impact. So our plant is located in Andhra Pradesh. It's in Anantapur district. It's an integrated steel plant. We produce special steel or alloy steel for the automotive industry. It's 300,000 tons capacity per year. We are next to a railway siding. We are close to the automotive market. We generate about 70% captive power. We are fully certified to serve the auto industry. We have a workforce of about 1,700 people, a very young workforce, so that's a good advantage for me to push forward some of these concepts. Products we make is alloy steel bars in various profiles, heat treated and bright bars. We have strong management systems in place, which is a basic bread and butter for being in the automotive business. We started the process of digitalization and bringing certain IoT solutions where it helps the business improve its efficiency, consistency, reliability. I'll have the examples after that. We have a good quality assurance system. Main market is automotive, but we also sell a bit into energy, railways, and some infrastructure areas. So we have a vision to create value for our shareholders. That's the most important thing. And to be in India a leading special steel producer, and I'm happy to say we are probably in the top 3, top 4 among various customers. And the kind of company we want to build is a company that's open and where people are accountable and they are fully empowered to take responsibility seriously. So we have, this is the process. So we have a coke oven plant, we have a blast furnace, mini blast furnace, we have a center plant, PCI, BOF converter, ladle refining, vacuum degassing, casting, and we have fully automated and semi-automated inspection lines. So we basically check the post the rolling of the bar, we check the internal soundness of the product, surface defects, any cracks that may open up when forging. So and then it automatically detects and pushes the product out for rework. Some of it can be reworked and reclaimed, and some of it ends up as non-prime. So today, our rejection rates, online rejection rates are about maybe 15%, but after recovery, we are within, it depends on the grade, we are within about 2% after recovery. So where we want our inspection to be strengthened and AI to be more helpful is we want to predict where these kind of defects, because some of these defects happen in the rolling and some of it happens in the casting. And it's too late to go back and cast. And so that's where some of our challenges remain. So those are products that we make, and those are the kind of applications our steel ends up in. And we are approved by most of the OEMs, and we go through a fairly rigorous process and testing of our steel for particular parts, and then we are approved as a quality supplier, and then we build up the volume with them slowly. Coming specifically to our initiatives, one of the things we are very particular is basically to protect ourselves against any cyber attack. This has been increasing over the last 2-3 years. There's a lot of spam mails, of course, but there's also people trying to hack into the systems. And we have fairly rigorous systems put in place. And also we do, what shall I say, ethical hacking to see where our system is vulnerable. Business has grown thanks to IT. This is one of the, I would say, complaints from my IT team that they are in the background helping much of the business, but they don't get the limelight or the recognition that one needs. So that's an area we are working. We have a lot of enhancements because as we get into new customers, new applications, the system constantly needs to be changed and adapted. So we have a set of various tools that help businesses. It's all, you can say, suited to that particular need. And of course, some of it we are doing. Predictive maintenance is one thing we are doing. Flexible production, how to increase and our yields at the melt shop. And basically, there's a lot of, we have a development team that is working real time. And our infrastructure is I'll just come to that in a minute. So basically, as you can see in this, it's a generic picture, but basically, depending on the work function, the complexity and the solution varies, right? And also the impact. So always our digital initiatives are supported by what it can do for the business, and in whether it helps us save time, money, reduce costs, increase the available time of the various units, and that's how we measure. So basically, we have obviously PLCs and SCADA systems in different parts of the plant, and above that, there is a program called QMOS, which is kind of similar to some of the systems we talked about earlier, where it allows us to feed recipes of various steel, take samples, all the chemistries move from one process unit to the other without any human interaction. It also tells the operator what kind of ferroalloys to be added, etc., and supports the operator in his decision making. So this is specifically designed for the special steel industry. It's predominantly used in the US and some other parts, I guess. And we also now have a QMOS developer in our office looking to improve the capability of that system. So we have introduced in different areas solutions that help that particular function. So alloy calculator for optimizing the alloy mix, where clearly there's a quality impact and a cost impact. RFID tagging for in and outbound vehicles, billet tagging to trace billets. So we have a 3-strand caster, so X, Y, Z. We are tracking the quality issues right up to which heat it was made and from which billet the problem happened. We have this MES system called QMOS, which runs across different units. And then we have a core digitization. So basically, any operational or IT systems are all on a single platform. Now we have migrated to Office 365, and most of our systems or solutions are based on the SharePoint platform. And now we are in the process of developing some business analytics to help us take decisions faster. So these are some pictures of how we capture the weight of the bundle and how the tag is printed and how it is validated through a mobile device, because often the operator is out in the field in the bar yard and he needs to know which bundle to, because one of the critical things that we have is the wrong grade and the wrong item should not go to the customer, because once it's processed and becomes a part and goes into the vehicle, the consequences of the commercial consequences of mix-up is too high. So we have to make sure that not only we make the right steel, but also the right kind of right steel loaded on the vehicle. Down to 2 hours or 2 to 3 hours in the short term. Can you still see me? My computer says my internet is unstable.
Mr. Krishnamurthy, sorry to interrupt you. I think your connection is a little weak because your voice is breaking off.
Okay. How about now?
Yeah, it is better now.
Well, let me try my best. So we also have barcoding on various bundles. This helps also locate inventory and store our inventory in a more intelligent manner. We introduce mobile plant maintenance. So basically, we have a barcode on the different equipment, and whenever a maintenance is done, entry is made into that particular asset when it was last maintained, and so it operator actually went there and did something, and we have also better control on what exactly the assets that we have and how efficiently we are maintaining it. We have introduced also on the back of SAP through the success factors module, a lot of the HR functions. So wherever we are on mobile as well as online, we can do certain functions which has avoided creating paper forms. And now we are slowly in the process of adding performance management as well. So all our targets, all our monthly reviews will be done through success factors. So we have moved away from acquiring computers, laptops, and wherever possible, we are leasing it. Everything is stored, and basically we have made it flexible enough. So when people are using the interfaces, there is no way data can be stolen or or virus can be introduced by inserting your memory stick. So everything is basically stored on cloud and also backed up. So in case of a crash of a laptop or something, we are not losing any data. And this lockdown also has helped increase the acceptability and use of all several features that we, frankly speaking, underutilized. So a lot of online meetings, collaboration using Microsoft Teams, sharing of documents, etc., has increased significantly, as you can see in the last few months. We have 3 branches: Bangalore, Chennai, Pune, and Faridabad are offices, and Tadipatri is the plant. And we are all linked on a wide area network, and it's dual on Airtel and Reliance. So we have made sure that if one fails, the other one is available. Before we had the issues of failure and data entry or entry of your sale order was all a problem, but now everything is with a backup. We are also working on a document management system now. So across the plant or across the various departments, all the sign-offs will happen online. So, and also the system will keep track of the jobs and also secure a copy. And the other thing we're doing is customer complaints and environment, health and safety metrics go on a platform. So we can trace back what are the issues. This is typically, this document management system is something we're just rolling out as of this week. So, and these are some of the projects that are ongoing right now. So we have stores where we are bringing in some level of automation in the stores, and also along with the warehouse management module, so that we have a number of duplicate items stored under, it's the same item stored under 2 different codes and unnecessarily blocking. We have intranet that is coming up. We have a self-service tool, so any change of password, you can manage yourself, the user can manage himself. And now we also have this e-invoicing, etc., that's coming. So overall, I think a lot of these solutions, as you saw, is more a business-focused approach. At the plant level, we have the QMOS as our core platform to drive innovations or automation. Increasingly, that will be our focus, where we can be able to predict some of these quality issues that I told you about, rather than react to it at the end. Thank you very much.
Yeah, thank you, Mr. Krishnamurthy. We have a couple of questions for you from the audience. So, Mr. Chandrasekhar, if you could ask your question. While we wait for Mr. Chandrasekhar, Mr. Prakash Manik. Mr. Prakash Manik, do you have a question for Mr. Krishnamurthy?
They're on mute, it seems.
Yeah, you may unmute yourself and ask the question. Okay, I think there is some technical issue. We have another question from Mr. Patra.
Yeah.
Mr. Patra, you may ask.
Yes, very good afternoon to Mr. Krishnamurthy. It was really nice to hear that this kind of digitalization in any steel plant. So I worked in Ispat Industries, and we used to think that SAP implementation in Ispat Industries, Mumbai, that is a benchmark. But with this digitalization of your steel plant, it appears to be really achieving at a very high level. So I like to know that you, as you are having all the management systems also implemented, is it are the systems are also on digitalized platform? I mean, are your documents, everything, and document control is also digitalized? Because after this 2015, your revision, all the management system standards are having uniform coding, and I mean, very business oriented. The clauses have been made like that. So
yeah. No, we are still, I would say, not fully on. The document management system has just come in. So going forward, a lot of those paper-based systems will translate into the online system. Still a lot of, I would say, the ISO certification, all that is still offline. But we have another software called, well, as you may know, Arja Steel before was owned by Gerdau from Brazil, and Gerdau exited India in 2018. And since then, we have done a management buyout along with a private equity firm and renamed this company as Arja Steel. So part of that legacy that we have a system called management reporting software, which was a Gerdau inbuilt in-house software, which they have given it to us. And on that, we track all the activities, all the minutes of the meetings, all the action points, and it is linked to your Outlook. So it pops up as an action to the relevant person, and if it doesn't do it, then it reminds him. So there is some level of, I would say, system there, but certainly all the audits and all the ISO systems need to go online still.
Okay, thank you. One more question, one last question. That is that you, I think, if you have heard correctly, you were telling that you're replacing laptops, computer by mobiles. I mean, is it so that people are using more and more mobile apps? So for inspection, validation from the site, people can refer the documents from mobile as well as their input can be given on the mobile. Is it so?
Yeah, not the regular mobiles. There are certain handheld devices that normally the crane operator, when he's at the when he's above, and he can visualize which bundle to go to, or in the yard they can trace which bundle to pick up. Those kind of things are on mobile. Laptops we are replacing with what are called virtual clients. So there's a keyboard and a monitor. There's no hard disk or anything. It's all linked to the cloud, and they work on the cloud. So most of the workstations are like that.
Okay. Okay. Thank you.
Thank you.
Thank you very much, Mr. Krishnamurthy, and thank you, Mr. Patra, for your questions. Anyone from the panel would like to add anything? Okay, so before we move on to the next speaker, I just want to mention to the attendees that if you have any further questions, you can just write it down in the Q&A section, and the panelists can then answer it there directly. Also, I would like to take a moment to thank our title sponsor, the Vega Group, and our co-sponsors, Smart Steel Technologies and Arja Steel. Moving on, our next speaker is Mr. Suman Das, who is the GM, IT and ERP, RINL, Visakhapatnam Steel Plant. Over to you, Mr. Das. Mr. Das, can you hear us? Mr. Suman Das, can you hear us? Okay, I think while we wait for Mr. Das to okay, Mr. Das is back. Mr. Das, can you hear us now? We cannot hear you, Mr. Das. I think it is muted from your PC or from your sound system. Your microphone is muted, not in Zoom. Mr. Suman Das, we are not able to hear you. If you need some time to fix the microphone, then we will move on to the next speaker in the meantime. Is that okay? Okay, so moving on, our next speaker is Mr. Manish Bhatt, who is the Digital Sales and Marketing SMS Digital. So over to you, Mr. Bhatt.
Thank you, Ankit. So the topic for today is primary and secondary steel making. So in last webinar, we spoke about learning steel plant as a whole. And today, we will focus on primary and secondary steel making. So when we talk about learning steel plant, there are 4 different categories you would like to focus on, starting from the asset health, then you would move to product quality. Then next step would be production planning. And in the last would be the energy. And of course, you need machine learning algorithms. And with this, typically our customers are able to achieve 6 to 8% EBITDA improvement. So let us look at these categories in detail. So when you talk about predictive asset health, your main target is to have lower maintenance cost or lower downtime. So your productivity increases. We have 39 references with various solutions in that. The next step would be predictive quality. So this is really important, that you are able to predict what would be your quality considering the current situation. So typical KPIs in here could be the lower cost of quality. You should be able to produce without downgrading the material, or in other words, you should be able to maximize your prime quality products. With predictive planning, basically you are trying to increase the EBITDA by improving the OTIF, on time in full performance, or by reducing the work in progress, or for example, you would like to reduce the transition slabs, for example. In predictive energy management, your aim is normally to reduce the energy and utility cost, or in other words, as Mr. Bandyopadhyay said, to reduce the carbon footprint. We also have 14 references in that. So these are more or less 4 different categories, and these all categories are important. But what is more important is the interrelation between these categories. So let us say you have production planning system. So when you make a plan, you would like to check what is your planned maintenance time of that equipment. And once you have this information of maintenance time planning, then you would like to consider this in your production planning. The next phase, maybe you would like to check what quality could be performed. So you get a customer order and then you would like to check with your quality system, can I produce this quality? And then you would like to get an answer, yes or no, and then you would like to make your firm production planning. But while you are checking the quality management system, then you would also like to check with process condition. So if my process condition currently are good enough to give me the, let's say, desired quality? If yes, then you should give a feedback to the quality system and again back to the planning system. And if not, then also the information should be available. So if you are trying to assess your condition monitoring or the plant condition, then you would also like to check what is the scheduled maintenance time. Let's say, for example, your hot strip mill is not at the peak performance or at the stable rolling condition, then you would like to check when is the scheduled next maintenance. And in that time, you will be most probably overcome this problem, and then you can schedule this product into the production planning system. So basically what we are saying is the interconnections between this different system of condition, quality, planning, and energy are really important. So of course, in the starting, you can have some quick hits. So you implement something small, you will get the result out of it, but it is the interaction between the quality system and the process condition, or the quality system and the planning, or the planning and condition. These are the areas where you will get the real value addition. So of course, we have process specific solution for each process unit. Then we have the data factory, which is a unique source of truth for everything. There are categories, 4 different categories in which all the solution can be met. And to the top, we have AI application. And in last webinar, we focused up to this area. So this time, since it is primary and steel making, we are focusing on, so I will focus on some of the AI application that would be applicable in those areas. So first example is a slopping prevention in converter. So here with this AI application, we are getting the audio and visual signal from the converter. We are also getting the level 1 and level 2 data, and combining both things, we are making the prediction model. So this prediction model is able to predict when the slopping is going to happen or why the slopping happens. And then based on this, this gives automatic process adjustment to the level 2, that what should be done to avoid this slopping so that the slopping doesn't happen. So it is not only detection, it is also prediction and the prevention. Typically, the customer are able to save $900,000 annually. We discussed something about alloying yield. So in secondary steel making, the main challenge every steel producer and special steel producer has is the prediction of the yield of alloy. Or if we talk about electrical arc furnace, you would like to predict the yield of the scrap or every chemical element in the scrap. So this AI application, this provides the information on the chemical composition of the scrap, for example, in EAF. So for example, in EAF, if you are having the scrap-based arc furnace, then the chemical composition of the scrap is usually a big question mark. But this being the raw material, this is also where you could achieve the highest impact to your OPEX. So based on the AI inputs here, we are trying to predict, or we are predicting what would be the yield of each chemical element. And based on this yield calculation, you can decide what would be the cheapest charge mix. Going one more step further. So now we are talking about whole melt shop, starting from the arc furnace to the caster. So when we look at the whole steel making operation, what you do in one step is important, but that is not the final goal. Your final goal in a steel making is to get the target temperature in the tun dish, or the target temperature during the casting. This is, let's say, the final target in whole steel making. And variation in this temperature can really impact the quality of the steel. Or as we discussed some time back, you would like to have really good hitting rate in this temperature. So this is basically the challenge we face here. because all the level 2 models are focusing on each process unit. So you have level 2 model for the arc furnace, ladle furnace, vacuum degasser, or the caster. But you need one module which is focusing on the whole steel making as a whole, and which is focusing at the caster temperature. So here, our solution is the combination of data-driven prediction model and of course our level 2 models or level 2 metallurgical models. So this takes the holistic view of complete secondary steel making. This also considers the ladle management system, or you could optimize your ladle heating with this. And once you are achieving this, then you would like to set the optimized target temperature or the planning temperature for the, for example, EAF or the BUF. And you would also like to improve the heating rate at the caster tundish. So overall impact, so this will not only save the cost in terms of heating. Of course, when you have optimized the tapping temperature, your heating cost would be lower and your energy consumption definitely would be lower. You will also get a better planning in each process station. So there are good chances that you will also be able to save on the processing time, or at least you will be able to optimize it. And of course, the final aim is to have a better quality. Another AI application we have is the caster cracks risk assessment system. So this AI application is predicting what is the chances of a crack in a slab. So here we are taking the inputs from the surface inspection system, then they are mapped to the casting events, and we are able to predict not only the cracks generated in the mold, but also the cracks generated due to primary or secondary steel making. Typically, we are able to reduce longitudinal facial cracks by 50% in one of the plants. If we are talking about overall quality solution, then we have quality execution system. So this is one of the example for the caster, because as we know, or as Mr. Bandyopadhyay already mentioned, that all the quality defects which are being generated in the caster, you would like to identify. For example, you will identify that some surface defect is generating because of the mold level, or maybe combination of mold level, casting speed, and the superheat. Then you would like to identify them during the casting, and then you can really act upon it. So this is the example of the slab report that you can get from such system. So one of the example in Shugang in China, so there the surface defects are 35% less after 1 year of operation, and payback only for this would be 1 million euro per annum. By the way, this system has more than 41 references worldwide. The last topic for today is the predictive energy management. So we have Viridis, that is the energy platform. And here you are focusing on energy efficiency, reducing the unit cost of the energy by better planning, and of course, overall energy management so that you reduce your carbon footprint. So we have multiple references in that. So till now we have managed more than 352 petajoules, so many customers worldwide. That's all is a quick overview of our AI application of primary and steel making. Thank you very much. You can reach me on this. Thank you.
Thank you very much, Mr. Bhatt, for a very precise and good presentation. So I just had a question for you. So the predictive energy management that you mentioned, what are the parameters that the model takes as input? What are the parameters you consider for the energy management?
So you need to take the parameters from your level 3 system for the planning. So what was the planning? Then you need to take the parameters from your level 2, because that is where basically the tracking is happening. And then you will also need some signals from the level 1. So level 2 and level 3 definitely you will need. And in some cases, also the level 1 signal. So you need to have connection towards all your process parameters, because then you would like to also understand, for example, how my energy consumption is changing from one product grade to another product grade, one dimension to another dimension, and so on. So you need to take data from level 1 to level 3 system.
Thank you very much, Mr. Bhatt. We have a question from Mr. Yogesh Kumar Patel. Mr. Patel, if you could ask your question.
Thank you, Mr. Ankit. Mr. Manish, I had a question that you talked about condition monitoring. So as today we are discussing about primary and secondary steel making, can you elaborate what are the critical equipments which need condition monitoring in a steel melt shop?
Okay, this could be a long topic, but see, one of critical condition monitoring equipment in the car, turret bearing. If it is a converter, then trunnion ring and so on, very critical ones. Then of big motors and so on, this would be critical. So, I mean, you could monitor every condition of every equipment, but normally one should focus on the critical and the big equipment where the failures are expensive. Also, the, let's say, HMO could be one of the most critical areas in the caster. So it really depends what plant we are talking about and, you know, what is exactly the mechanical design. But normally those are the big equipments you would like to focus for the condition monitoring.
Okay, thank you. I had one more question for you.
Yes.
In this converter refractory lining, do you have some method to measure the converter refractory lining thickness?
Yes, there are. Actually, we are working on a concept. It is under trial at one of the plants, so it is possible to measure the thickness of converter lining thickness. Maybe you can drop your contact number and I can contact you with further details.
Okay, okay, thank you. Thank you.
So do we have any questions from the panel for Mr. Manish Bhatt?
I think there was one question.
So yeah, we have a question in the Q&A from Mr. Narendra, and he's asking facial cracks related to the composition of the steel. How is it going to solve the problem?
Okay, so as you know, if the facial cracks are generated because of the composition of the steel, for example, due to specific chemistry, then once you know this root cause from this application, then you would like to avoid those situations in the long term, that you don't have the exact chemistry or what part of the chemistry or what exactly is producing that crack. And you would also like to know at what speed this crack is generated. If you could operate at lower speed, for example, and avoid the crack, you would like to do so. So, I mean, there are different ways and means. And as you know, those cracks could be generated because of multiple reasons, even in the chemical analysis. So for each analysis, you have to do the root cause analysis and you have to figure out exactly why this is coming. And once you know why this is coming, then you can definitely have a countermeasure on that.
Thank you very much, Mr. Bhatt. So we will now move on to Mr. Suman Das. Mr. Das, are you able to unmute your microphone now?
Thank you.
Yeah. Yes, I have unmuted. Am I audible now?
Yes, we can hear you now. So Mr. Suman Das, GM, IT and ERP, Visakhapatnam Steel Plant, RinL, is our next speaker. Over to you, Mr. Das.
Good evening to all my previous speakers and of course Ankit and the team of these organizers. I will be trying to present a small presentation on the steel plant process, what all the requirements of Industry 4.0 is there. Let me see whether am I allowed to share my screen?
Yes, so you have to first open the presentation and then you have to click on the green button on the bottom of your Zoom app. If your presentation is open on the background, then when you click on the share screen button, it will show up there. Then you can click on it and share.
Okay. Right. Is it visible now?
No, we are not able to see yet.
Here. Okay. Is it now visible?
Yes, yes, it is visible.
Good evening to all the participants for this late evening, and also to those who are from the different time zone. Good afternoon, or whatever is the time. Uh, what I am going to present here is in conjunction with our steel plant, the Visakhapatnam steel plant I am belonging to, regarding that Industry 4.0, what we do and what we expect. Here you find that it is only the definition of what Industry 4.0 says. I think all the audience here and the panelists, they are all aware. Still, I say one thing only in this regard is that it is expectation of the industry that the computerization level further improves, and it helps in avoiding human touch or dependence in the production process. And any steel plant will look for two things. One is productivity improvement, cost reduction, and basically quality management, better quality management. Am I audible now? It's okay now?
Yes, we can hear.
Hello?
Yes, you are audible.
Okay, right. While doing this Industry 4.0 technology implementation to steel industry, we understand that few things which gives us the strength. One is digitalization, going by production history, then traceability of products 100%, use of sensors and Wi-Fi for IoT, intensive networking and communication, and also handling of uh, usage of big data analytics and AI ML, these areas. Okay. While doing this study, actually being a last presenter, or maybe last but one presenter, many things are covered earlier, but still to have the continuity of the presentation, I still require to repeat a bit little of them. The generic area of projects, what we understand are important from steel plant point of view or from the manufacturer point of view, are power and energy uses versus production monitoring for cost optimization. We should always try to track that how much power and energy we are using, so that the cost of power and energy per ton of steel production is minimized or optimized. QR code based maintenance using mobile applications. This QR code can be used for easy identification of any equipment, and while we're doing the maintenance, it can be easy to take cognizance of what all the things has been done, the history, case history, and if any problem is identified, to take up for future maintenance activity or immediate repair or replacement work. The GPS based complaint system, there are certain areas where a person goes in a mobile, he wants to give a complaint like lamp is not glowing, or road is bad, or anything. I mean, any equipment is giving some extra noise. If a GPS based application is there, he can directly put the complaint only. He need not identify the equipment and other details. If he is not able to identify those details then and there, this can help in taking the complaints and taking a fast rectification action. The other thing is that drone-based inspection of structures. I mean, drone can be used for various purposes. It can be used for seeing the material stock position in the yard. I mean, not for finished products, but for raw materials. So drone can be used in a good extent for a steel plant, and it can be a part of this industry 4.0 implementation. Similarly, a few more things are there, like gas detection system for a safety. If some trace of gas like carbon monoxide or some such other gas is there, so those gases like BF produces gas, coke oven produces gas, and steel melt shop also produces gas. So gas can create fatal accidents or some disablement. So that is also one important thing. Similarly, creating suitable interface with level 1 system, so that if level 2 system is temporarily not available, still the production can go on without level 2 system, but the parameters can be passed on to level 3 or level 4 ERP system. Usage of sensors to get online vibration temperature for critical equipments. Already one of my preceding speaker has all pointed out. Then water level measurement at reservoir, because as you know that steel plant requires a lot of water, and for Visakhapatnam steel plant we require to store in reservoir, and many other steel plants also requires it. So that is also one important thing. QR code based QR code based uh, material tracking, that is also traceability. That is also one important thing. QR code based maintenance is also another activity what we take up. So QR code is also nowadays being taken very predominantly and extensively. I will come back to this problems, those which are generic problems for different plant operational areas. Like blast furnace handles hot metal ladle, which it sends to steel melt shop, and tracking them becomes important, because certain times it happens that because of some problem or because of some reason, the hot metal ladle is kept on that siding, and it is again hauled to the steel melt shop after some time. And this is one important thing. By mistake, if that ladle is allowed to remain there for a longer period, then the temperature comes down and it becomes irrecoverable. It is a loss for the plant. It cannot be charged, or further use may not be possible. That is one part of it. Then rolling mills has got certain areas of expectation from this industry 4.0, like prevention of low temperature rolling, detection of blades and cobble issue. If it is detected in the beginning itself for the first case of happening, then that can help further production, further production of defective products, and it will help in cost cutting, or rather cost optimization. Similarly, steel melt shop has got certain requirements like billet and bloom identification using marking or spraying of from machines, so that the billet or bloom, whenever it is either directly dispatched or it is used for further rolling, they can be correctly identified and properly rolled. Because when the production is high, production is quantity is more, then there will be various grades and various production sequences, heats will be there. So there is a chance of mismatch, there is a chance of mix up, and people may make mistake, ultimately leading to suffering of the customer and customer complaints. Usage of thermal imaging to check lining condition. We should have a lining conditions, thermal imaging facility so that there is not much of cracks or damages, or we can predict that further lining cannot be used, continue to be used. Use of handheld devices for ladle number entry from pulpits, then measurement of hot metal steel weights, hot metal or steel weights in ladle converter. It can be done by radar level instrument and suitable empirical formula fixing up. SMS converter sometimes gets charged with scrap, and how much scrap is being charged, that should be identified, and depending on that, the quality of the material output and additives to be added can also be decided. So that is also one important thing which can be in Industry 4.0 can be addressed to SMS casters data transfer to big data environment for further analysis can be used. Ladle carrier tracking using image processing and photo barrier switches inside the shop, that is for basically for steel molten steel ladle can be used. Similarly, it can be used for handheld devices for billet and bloom inspection. If it is billet or bloom is put with some embossing or painting on such thing, or stamping, then that information while dispatching the billet or bloom, the handheld device can be handy so that dependence on human being will be less. Steel temperature in tundish monitoring to avoid choking, machine closures, etc. is important. Vibration load centers for critical equipments like lance drives, converters, BOF tilt drive, etc. Continuous monitoring can be of very important, and it can give whenever there is a alarming level, then it can give immediate information to the shop in charge that there is something is going to happen, so further immediate checking is necessary. Similarly, steel ladle lining scanning and data transmission to level 1 for predicting ladle failures and such things can help in avoiding ladle through or such type of problems. Scrap box can be tracked based on RFID. Ladle thermal tracking model can help in predicting the temperature in the ladle. Steel ladle tracking system by photosensor based can give the position where it is now, so that which one is earlier and which one is later can be identified. Hot metal weight prediction also can be useful for measurements and prediction. Finished product. Now I am going for customer centric certain requirements which also are very important. One is tracking finished product till the customer custody for quality and production information. This can be achieved, and possibly many of the players are achieving it also by either barcode or QR code, and with such a way that it is not easily destroyed. It will be having life, and so that it can be seen, and by seeing, customer himself also can know what is the lot of this production, what is the grade, what is the property, and other information from the QR code data. Provide availability information for the customer to plan their procurement. This is another thing we can because the steel plant, our steel plant produces mostly structurals, long products. So we produce not exactly based on only customers' requirement, but we produce based on optimization of other factors, including customers' requirements. So whenever there is a requirement at some branch location outstation, the customer can know beforehand that when the material can be expected to be available in the stockyard. Tracking of dispatch material till reaching the destination. Once the material has been dispatched from plant, it can be tracked till it reaches either the stockyard or customer premises. However, in doing this, in achieving this, we see that there are certain challenges, which includes security and reliability of the data. which is being communicated, extreme conditions of operations, upgrading of existing system and facility. Usually it is not that the steel plant is not running with computerization. Level 1, level 2 systems are working and material tracking is happening. But when we want to add something extra, then existing equipments, signals, there are certain cases, analog signals and such things are not readily available, readily possible to be converted for Industry 4.0. So how to improvise on that to make it compatible. Compatibility issues addressing is important. Interpretation of the collected data is also one more thing. We may get lot of data from level 2 and maybe from level 3 also, and how to interpret them for our benefit, business purpose. That also requires a thinking process and some workout with all the people in the area and who can have such vision. Anyway, but talking about the outlook, without the Industry 4.0, many of the technology applications would become incomplete, and probably the process which is not Industry 4.0 compliant will become obsolete. We should make a way out for existing units to upgrade cost effectively. For all the forthcoming infrastructure, maybe Industry 4.0 enabled. Means suppose if you are going for some new installation, new facilities, then it should be Industry 4.0 enabled. That is what we feel. Anyway, in one of our preceding speaker, Mr. MP Dubey has already told that Center of Excellence is being established in the premises of Visakhapatnam Steel Plant. Of course, by MIT and STPI, they are working out on this. So what we expect that will also be playing a major role in making Industry 4.0 successful for many industries in this area, including steel plant. I end here with this presentation, and if any questions or other things are there, may please come forward.
Thank you very much, Mr.
Thank
Das.
you.
Thank you very much, Mr. Das. So do we have any questions from the panel? Mr. Dubey, would you like to add anything to Mr. Suman Das's presentation?
I think both of us were working on the same area. The idea is to bring more and more Industry 4.0 based application in a steel plant. And here actually what we are doing, we are taking some of the partners also, like Daniel is there, SMS is there, EOS is there, Siemens is there. And through this forum, I am requesting that if other people also can join us, because this will strengthen the overall steel industry. And some of the mentors who want to voluntarily come and mentor our startups. Thank you.
Thank you very much, Mr. Dubey. So since we are running behind schedule, I would request the attendees to post their questions in the Q&A, and Mr. Das can directly answer it there. So without further ado, I will move on to the next speaker. We have Mr. Andrea Barachini, DG and MET and Director Sales, Danieli Automation. Mr. Barachini, please take over.
Thank you very much. Thank you for hosting this nice webinar. And I'm thanking in the name of Danieli Automation and Danieli Group itself, Vega Group, Steel Metallurgy, and all the sponsors for inviting us to attend this meeting. I hope you can see my presentation on the screen.
Yes, we can see it.
Okay, so the topic of today is, of course, to look at Industry 4.0 for primary metallurgy, but with the perspective of the sustainability. The topic, let's say, at first sight might seem that regulations due to the limitations that superimposed by some government rules or by the economic and environment conditions are barriers against the development of new technologies. But in the other side, they hide new opportunities that can be applied also to the steel business. As a matter of fact, that the energy utilization in primary and secondary metallurgy is constantly decreasing. From the last decades, you see on the graph, there is a trend of lowering of energy consumption, reducing of process times, and also improving in the equipment wearing. In the graph, you see the how long electrodes consumption is reduced in the last few decades, for example. So modern technologies and combination of continuous seek for reduction of operating costs, together with increasing attention to sustainability, are boosting research and development of new solutions for steel producers. One example is the use of alternative energy sources like solar energy, for example, to reduce energy consumption and then reduction of emissions that are polluting the atmosphere. RinL Automation, always looking for innovation and new solutions on the steel business, has developed the hybrid melt shop, which combines the use of renewable energy sources with new active digital system called Q1 that changes completely the way to inject energy and control the arc electric furnaces melting process. But we face today a transition that is going on day by day to a more efficient and sustainable operating plant. And this transition is driven by many accelerators, like improving the energy and material efficiency, introduce innovative and low carbon footprint technologies. This, in many cases, as we said, is due to the government regulations that are superimposing, which are limiting CO emissions, for example. Of course, another accelerator is the management of the use of the energies. And last but not least is the possibility to utilize large amount of information gathered from the plant to retrieve useful information from that. All those enabling technologies are contributing to create the so-called intelligent plant. That it is made with the aim to further and continuously optimize the operating costs and also look at the sustainability of the process. The factors which are contributing, which are creating an intelligent plant are a modern automation system, capable to monitor the equipment and the energy consumption in real time. The use of robotic applications to reduce manual interventions, and on the other side, to preserve human beings from the exposure of dangerous working conditions. And then we have all the new horizon offered by the artificial intelligence. The intelligent plant is capable to self-optimize and to improve production process and product quality. According to the RinL vision, an intelligent plant is equipped with the Q3 pulpit, a new concept of plant supervision, where the decision makers, the foreman, the users, are supported other than the traditional other systems that we are familiar with, also by analytic tools, predictive systems, which provide guidance to the operators aside to the classical model-based approach. Such plants are designed to be managed from one unified control room, where smart controls are supporting operators, and the number of people required to be present on the field is always less and less, targeting with no man on the floor. Such technology is a reality today in the RinL, and it applies already in the plants that we make for our customers. You see some pictures taken from the most recent projects that we executed worldwide. One of those is the Danieli Universal Endless Mill in Shogan-Jintan, an high-efficiency plant where the melt shop and the caster are linked together to up to the hot rolling. The next generation pulpit is a concept where the automation system is interacting with users to enhance the perception of the operators of a dynamic process which is changeably together with the material flow into the mill. The next generation pulpit will interact with operators, offering them the right information at the right time based on the actual process going on. Plants, modern plants, are crowded of data sources. It is possible to collect a variety of information from different sources along each of the plant and apply on top of this data business intelligence techniques using tools like Q3 Intelligence that allows us to translate such very big amount of data into useful information. Then it is that becomes, let's say, a trigger for the process monitoring, for detecting anomalies, and for monitoring of the consumptions. The benefits of this kind of approach are immediately understandable if we look at the perspective of the yield optimization, the reduction of number of defects, and also the limitation of the energy consumption. If we want to move forward and be, let's say, online, contributing with the guidance of the process, then leveraging of our experience in terms of process control, leveraging on the Danieli know-how on the metal business, we have developed a platform called Q3 platform, dedicated to the implementation of statistical approach and artificial intelligence solutions dedicated to specific needs of the steel business. Such artificial intelligence solutions are embedded in the platform, and the platform can be provided to our customers in different ways, like in a more classical approach as an on-premises installation, a fully cloud-based solution, or even a mix of the two. Especially in this time being of limitation of people interaction and movements, the flow of information has become a crucial factor. For the activities where human intervention is still a must, like maintenance operations, for example, we are adopting QSpace One, a virtual collaboration platform allowing to share videos, proposing advanced collaboration functions, sending and receiving virtual contents, and tracking of activities performed. This kind of system, it is utilized from the early stage of a project, supporting surveys, especially when we talk about modernization of existing plants, supporting the tests before dispatching to the site of the new equipment, and also support to all the commissioning and post-commissioning assistant activities. I'm showing you a short sequence of images captured from our FAT test, factory acceptance test execution performed with the technician of the RinL automation in front of the real equipment, and the final customer sitting comfortably in his office, interact each other to QSpace One to follow the responsiveness of the software with the commands imparted during the testing procedure. So in conclusion, sustainability has shown to be an opportunity. The near intelligent plant is sustainable, allows to reduce costs, increase yields, and with the eye of product quality. Operator experience is enriched, making them, let's say, assisted by the new technologies in daily operations. And all information is put together, let them have a real picture of the actual situation on the fingerprints, supported by instructions given by artificial intelligence-driven algorithms. No man on the floor is also a must in our business, with a double aim, as we said before, to reduce exposure of dangerous conditions of operators, and also to optimize the use of resources when driving a model plant. The collaboration is a crucial factor for daily activities, for maintenance purposes, and then also to solve issues very quickly with the remote connection, with no need for material transfer, people movement, and having immediate contact with the plant. This is the end of my presentation concerning the topic of today. But if you allow me another couple of minutes, I take the opportunity to introduce another topic that was mentioned several times during today's presentations. Just to inform that in Daniele, we have already received many of the feedbacks
Yes, Mr. Barakini, you may continue.
Can you hear me? Okay, good. Yes. So let me close this presentation and I switch to the other one. So one of the issues which was mentioned earlier during this meeting was the necessity to track the equipment around the plant. And one of the solutions that I want to introduce is the Ladle identification and tracking system. Our solution is based on the need to track the physical presence of the hot metal and steel metal ladles around the plant to have real-time and 100% trustable information from such kind of sensors that I will present you, capable to detect the presence of a steel ladle anywhere in the plant. Typically, this issue was solved in the past with manually performed operations. So it was in the hands of the user, of the operator, to take notes about the ladles, assigns ladles to the proper running heat, and coordinate maintenance activity based on the notes he took during the process. We have got also the opportunity to test different technologies, and we found that some of them are not let's say, suitable for, especially for primary and secondary metallurgy environment, where there is metallic dust and a lot of metallic pollution disturbing, for example, an RFID system. Of course, we are aware about the critical aspects that are behind the identification of a system. So we work in a high temperature environment, and we are exposed to to dross of material, which sometimes can even damage the equipment. So our solution, applicable to any steel carrier inside the melt shop, ladles, whatever Standishes or torpedo cars, is based on a encoded metallic plate and a vision system capable to detect the presence of a ladle in a specific area, like you see in the screen in front of you. On the left side, you have the image captured by the camera which is placed in a fixed location. On the right side, you have a record of the presence of a ladle in front of the camera. The log of the ladle is recorded whenever the ladle passes in front of the camera. So we got immediately the information which ladle it is, which is the direction, the moving direction, is the ladle arriving or is the ladle departing, and also the time stamp of those events. So a very simple system with already several installations worldwide, practically with zero maintenance required, apart from some cleaning time to time, with easier integration with existing automation systems. And as I said, we have a few installations already in Europe of this kind of solution that are showing 100% recognition capability. So very reliable, and the level of investment is very low compared to the possible, let's say, issues that you may occur when damaging a ladle or polluting the steel, for example, with the wrong grade. Okay, sorry for extending my presentation further than the topic, but I found it could have been useful for somebody to hear that Daniele has also this kind of small packages available.
Thank you very much, Mr. Barachini. And I recall back in 2012, we covered the Daniele Q3 pulpit. I think it was called the 3Q pulpit back then. And of course, the 3Q standing for quality, quantity, and quickness. And it's wonderful to see how over the years, the technology has been improved upon and developed over the generations to where it is today. So thank you for a very, very nice presentation. Do we have any questions or comments from the panelists? Okay, then I will now move on to our last presenter for today, Mr. Karthikeyan PS, Digital Leads for Metals and Mining, ABB. Mr. Karthikeyan, thank you for patiently waiting, and over to you now.
Thank you so much. So just a minute. So just give me a heads up when the presentation is here.
I think we'll be able to hear a bell after 10 minutes.
No, that's okay. So yeah, so are you able to see my screen?
Yes, we can see.
Yeah, so first, thank you so much for this opportunity. And it was very extensive, resourceful, and insightful session until now, wherein we are really talking about a lot of holistic and point-specific solutions for metal industry. So just to to start with, what ABB actually is trying to master or even mastering is this. So we both have the complete holistic view, and also we have a point specific view when it comes to digitalization of metal industry or any industry for that matter. So as you can see, what are the aspects that when we really are involved when we really talk about the complete metal industry is you have planning, you have stockyards, you have primary metal areas, you have your hot rolling, cold rolling processing areas, and then you have shipping, right? So the complete plan starts from your inbound logistics processing, and then it kind of ends with outbound logistics. So we are really focused in many places wherein we give at first we facilitate the end-to-end visibility, so that because traditionally, as many of you are aware, still most of the processors are working in island. So we firmly believing in first connecting all of them and giving an end-to-end visibility, and that opens the doors for optimization. And of course, in each area we have solutions at place which can improve the performance and optimize. For example, in planning, we have a very good production planning suite. And for stockyard, we have a stockyard management system which can completely run your stockyard autonomously without any manual intervention. So when we come to primary metals area, we have advanced process control through model predictive control, and everyone we have performance optimization for mill shops with a ladle tracking and with very accurate thermal models, which is running very successfully in one of the largest steel plant in India. And we have for rolling, we have point solutions like analyzers, mill analyzers, which will minimize downtimes, production loss, and then which will also improve the quality. So this is one part. And the second, when we really talk about all across the plant, so the other aspect is, of course, the digital infrastructure, the enterprise information, mobile workforce, health and safety, smart asset management, and utilities optimization. So these are the other underlying aspects wherein we are also broadly working in every area to give solutions, to facilitate all of this, because this kind of gives you a very holistic set of digital solutions that you can operate with. So probably I'll not spend much time on the point solutions from here on. Probably I'll quickly move to one of our latest solutions, because everyone we are talking about, just give me a minute to skip through that. So just a minute. So yeah. So what we really also want to talk about, this is all about optimization, ML, AI and stuff. So I would really like to introduce to all of you about ABB Ability, Genix Industrial Analytics and AI Suite. So what this actually does, this is a holistic analytics and AI suite for industries, which makes operations and asset optimization easier than it looks. So just to say, how do we really adapt to industry 4.0 digitalization phenomenon? So it is about integrating all the data, so that is from OT, IT, and ET, and expertise in enterprise-wide data analytics and industry-specific data models, and then ease of implementation and rapid rollouts, because this is more important, because whenever you talk about an analytics suite, for example, let's say you talk about a predictive model. So there are a lot of, and it's really easy to talk about predictive models. So what is more important is how easy it is to implement those predictive model and how rapidly we are able to roll out it. Because building a model and implementing it can take anywhere between 2 days to years. Right? So this is something that really focused on ease of implementation and rapid rollouts. And then finally coming to maximizing the asset utilization, failure protection, and also equipment lifecycle management. I'll probably show you, this is the framework wherein we really first enable through IoT, soft sensors and data, and then we integrate all the data from all the system, and then we build, model, analyze and deliver. Probably I'll give you some case studies wherein a few modules, talk about few modules. So this is how it really looks like. So first you have all your sensor systems, engineering information systems, enterprise systems, even social systems. And then you have your edge built in, so wherein you integrate all the systems through various edge, so which comes into system digital twin integrity hub, and then it has a cognitive data lake. So when we really talk about this is industry cognitive model wherein each data is contextualized according to asset operations, safety, and then you have your analytics app studio, model fabric, so through which you can really make targeted models for this. So just to give you a small example, so this Genix has a module called system anomaly detection, right? So what is this system anomaly detection? Is once you have the right data, for example, for your rolling mill, so this on its own will detect the anomalies in operation. So which will help you reduce unscheduled trip, which will help you increase the plant availability. Because what happens is 80% of the failure actually happens randomly, and so what it will do help is it will help you analyze the patterns and then detect anomalies, which will alert you in prayer so that you can take some actions, and then you can really minimize the unscheduled trip time. So similarly, also the other thing that I really want to talk about is another built-in module called opportunity loss manager. Right? Because when we really talk about digitalization, we are really looking at the business value. So this is the module which will really look at the opportunity loss at each and every processes. Because how do I really define an opportunity loss? For example, let's say performance of a furnace can be, it could have been with set parameters could have been running at 80% efficiency, but for some reasons it was actually running at about only 70% efficiency. So probably 70% efficiency is quite good, but then we still have a hidden loss of about 5 to 10% just by tweaking some parameters, just by changing few parameters, making few changes. So this hidden losses or opportunity loss broadly is something that is inherent to every process and operation. So what this module does is, it analyzes your data, and it really detects the opportunity losses and throws it open to you, wherein as you can see here, it calculates the reliability loss, utilization loss, and then it creates the what is the total loss. So it really helps you to get into business perspective, because a lot of us are talking about a lot of solution, but at first point of solving something is identifying a problem, right? So this really helps you to identify the problems quickly so that we can really start acting on it. So the next is module for asset integrity. So when we really talk about asset integrity, what we really say, it enables a 360 degree view of asset performance. So really, for example, let's say you take a mill as an asset. So it can identify bad actors, reduce maintenance cost, and extend asset life with just the data that you have, just by processing the data that you have, and then to give the dashboards. So just to give you a perspective to close with, for example, what is the advantage of the solutions, host of solutions from ABB? First, we are the pioneer and thought leader in automation and digitalization. And we come with a deep domain knowledge and understanding of processes. So through which we really provide reliable solutions through our premier ecosystem. So with consistent track record. So this is something, very simplified, scalable, smart, speed, and secure. Because at the end of the day, when we really talk about AAML models, you really need to have a good ecosystem which contextualizes the data, and which use built-in modules which helps you identify the problem and improve the performance and optimization. So this is something that is readily available without much custom development. So so I just since all of us were talking about very point specific solution, I thought I would diverge a bit and focus on this. So thanks for the opportunity. Thank you.
Thank you very much. Thank you, Mr. Karthikeyan, for your presentation. So do we have any questions? Okay, so we will now move on to the last phase of our webinar today. I would request Mr. Shubrata Mitra, Chairman of our Organizing Committee, ex-Joint Managing Director, MN Dassur & Co., to just sum up the session of today's proceedings and just give us his conclusion and his remarks of today's webinar. Over to you, Mr. Shubrata.
Thank you, Ankit. Thank you, all the panelists. It was quite an absorbing, and a lot of initiatives could be shared. Apart from knowledge, what is happening in the industry 4.0. It was quite a year. Totally, we had, including me, welcome address, of course, 9 panelists. Shobhasachী Bandyopadhyay, CTO, Big River Steel, spoke on his transition from totally manual operation plant to a modern tech in Big River Steel, Arkansas. He spoke on repeatability and reproducibility, which makes the output consistent. So he gave a figure of 3,000 ton per person per annum, which is of course a definitely high production figure compared to us. And he spoke on, we have to focus on CO2 emission because the world will ask us through AI, what is the CO2 emission which is happening in the plant? Then the next keynote address was given by Mr. MP Dubey, Director Software Park AP. He is working with CMD RinL under the leadership of CMD RinL. Elaborate park and elaborate initiatives are being taken up there, which is really great. It is Center of Excellence, AI, 3D printing, VR, AR, cloud computing. Main focus is on AI. We came to know the AI market is having 17% CAGR growth. Machine learning spoke about. Center of Excellence is doing data analysis. Many places, this Center of Excellence is being established with the main in Vega Steel. Ministry of Steel, IT, Ministry of IT are all involved in this. Spoke on artificial intelligence in primary steel. Then the fourth speaker was Vega Group, gave a presentation by Mr. Purandare, MD, assisted by Yashwant Sataru, ED. They spoke on productivity. Mr. Purandare spoke on productivity and profitability and various initiatives they are taking. Their focus was on secondary steel making. Gave presentation, the focus of management aspects and process. Data available is taken from the real-time analysis, sales price, cash flow. These are the areas which they are working on, which gives a total business profile. Spoke on impact of Industry 4.0, raw material movement, real-time values of raw material movement. Then the fifth speaker was Dr. Falk Heinrich. He spoke on smart steel technology, where reduction of surface defects through artificial intelligence in caster. This was quite an interesting. In rolled and galvanized sheets, in steel making platform, EBITDA impact, what he showed is 6 to 7 million euro per year based on a typical 5 million tons per year plant. This is only achievable through precise planning and precise operation to make these things smart action successful. Machine parameters on a question, what he clarified, machine parameters are set for no surface defects operation of the caster. And the sixth speaker was Mr. Sridhar Krishnamurthy, MD of Arja Steel, this erstwhile Gradau Steel. He gave a presentation on the Arja's plant in Tadiapatti. He described the 4.0 initiatives being taken. One thing we could know that they received a CII award for national excellence in digitization. That was a good reward. Predictive maintenance is being followed, has manufacturing execution system being practiced there. Digital ecosystem has been developed there. Now developing business analytics. HR success factors are being introduced through SAP. Cloud storing is being used. Then the seventh speaker was Mr. Manish Bhatt of SMS Group. He spoke on predictive energy management, production planning system, spoke on maintaining efficiency, condition, quality, planning, and energy. These are the 4 interfaces what they are doing through their AI interface. Data based on predictive system. Then the seventh speaker was Mr. Suman Das, GM, IT ERP of RinL. He presented the activities and initiatives of 4.0 at RinL. Again, the same thing, they're aiming at creating a smart factory through digitization, traceability, big data analysis. Cost of power and energy are being calculated because these are the two costs which affect the steel cost. QR mode of maintenance discussed. He discussed the problem areas of the plant which affects the profitability. Customer-centric approach is being taken by RinL. Then the ninth speaker was Mr. Andrea Baracchini of Danieli Automation. His topic was simplifying steel making complexity. That's interesting. Evolution of EAF technology benchmarks, he spoke. Use of all energy, alternative energy sources like solar energy is being practiced by Danieli. Hybrid process, discussed driving the transition. They're driving the transition from the old system to the new. Spoke on enabling technologies. Intelligent plant is the focus. Discussed next generation pulpit design. Spoke on business benefits. Q3 platform, QS approach for human interface, and remote commissioning that already Danieli is carrying out in many countries. Then the 10th but last panelist was Mr. P.S. Karthikeyan from ABB. He also spoke on smart metals plant, showcased ABB's initiative on digital infrastructure, mobile interface is being practiced, which other speakers also spoke about, and holistic setup. ABB's ability, GenX, industrial analytics, maximization of asset utilization is the focus which they are carrying out. Asset integrity is one of the main topic. So in short, it was quite an absorbing and knowledge-based discussion, and hope everybody enjoyed, and thank you once again for your inputs.
Thank you very much, Subroto uncle, for your comprehensive summary as always. So thank you all for joining us, and I would like to wrap up today's discussion with a few closing remarks. First of all, I would like to thank all the panelists for being here today to make the session such a vibrant one. Thanks to all the attendees as well who have joined us on Zoom as well as on our live streams. Special thanks would go to our keynote speaker today, Mr. MP Dubey, who despite being the first speaker is still with us now after 3 hours of discussion. Thank you, Mr. Dubey, for staying here so late. My heartfelt gratitude would go out to our title sponsors, Vega Group, and our co-sponsors, Smart Steel Technologies and Arja Steel. A special thanks to everyone in the organizing committee led by Mr. Subroto Mitra and Mr. Shabboshaji Bantopadhyay, and to everyone from the Steel and Metallurgy team for making this event possible. I would like to thank my father, Mr. Nirmalya Mukherjee, who unfortunately could not be here with us today for health reasons. And I would also like to thank Amitech India for their technical support. With that, I would like to conclude today's meeting. Thank you all very much for joining us today. Thank you.
Thank you.
Thank you. Thank you. Thank you so much.
Good evening. Good evening.